Okay, so we're carrying on our merry way. We're going to start looking at an example and we're going to be able to define some things as we look at this example. So we're still in section 1.1. And this says, let's say we are curious in knowing how many or what proportion of 13 to 17-year-olds have been prescribed medication for a mental illness or disorder. How could we go about doing this? So what we would not do is we wouldn't survey everyone in the United States that falls in this category. Rather, we would take a small sample so we could take a small, put that in quotations, just that it's smaller than the actual population, small group, and then just give that small group a survey. All right, and then we hope that this small group is like all of the 13 to 17-year-olds that have been prescribed medications for a mental illness or disorder. Okay, so this is exactly what the Gallup organization did. We talk a lot about the Gallup organization. They are a credible agency and they do tons of these surveys. So they actually conducted this survey. And again, rather than survey all teenagers who live in the U.S., they just did a small group. And so in this case, small to them was 1,028. All right, so once they gathered all of these teenagers, they asked whether or not they had been prescribed medication for any mental disorders. And so now we're ready to define some things. The population are the teenagers in the United States. So in general, the population is the entire group of individuals to be studied and in our case that was all 13 to 17-year-olds in the U.S. Okay, so it's all of them. And then we focused on that small sample. Okay, so while we're here, we actually have another vocabulary word. We talked about individuals. And an individual is our next definition. So it's a single person that is being studied. So an individual is a single person. So is a person. It could also be an object. If we were curious about the weight of donuts, for instance, the donut would be the individual. So it's a person or object that is being studied. So that is, excuse me, a member of the population being studied. Okay, so in this example with the Gallup organization, this would just be one 13 to 17-year-old. Okay, so we're defining all of these lovely things. We looked at the population, we looked at individuals, and now we're going to talk about this 1028 teenagers, and that's a sample. That's a sample from our population. So a sample, it's a small group of the population, or we could say it's a subset of the population being studied. And so again, in this example, our sample was the 1,028 U.S. teenagers. All right, so we have our first group of definitions. Okay, so what are we going to do about this sample? Well, we're taking the sample to get information. And so the Gallup organization asked this sample of teenagers about prescription for their mental disorders. So of course they would gather their results, and their results indicated that 50 teenagers out of the 1,028, and that's a number I made up just for a demonstration, they have actually been prescribed medication for mental disorder. So how can we describe this result? Because 50 teenagers out of 1,028 is wordy, and we can't do much with that sentence as far as math goes. So this naturally kind of forms a ratio. So when we're talking about results of surveys, a lot of times we're going to quantify them. We're going to turn it into some sort of number. So 50 out of 1,028, 50 divided by 1,028 is 0.049. So we can say that as a proportion, or we could say that that's 4.9% of them have been prescribed medication for mental disorder. Oops. All right. So what this is, when we take the results of our survey and we calculate the numerical value, like 4.9%, that is called a descriptive statistic. So that 4.9% is a descriptive statistics. So what we did in that process, and we'll write it out, this whole process consists of organizing and summarizing the data. So descriptive statistics describes the data through a numerical summary, which is what we just did. That 4.9% is a numerical summary. And we'll see in later sections, we can also have tables, and we can also graph our results. All right, so that's going to be our descriptive statistics, and that's going to be the first chunk of this course. And then what we have here, our next definition is a statistic, and that is that numerical summary that we were talking about in that previous definition. That's that 4.9%. So a statistic is a numerical summary based on a sample. All right, so good. So we have taken our sample, we've asked our question, and we took that data and we got a statistic. So now what are we going to do with that statistic? Okay, so we have this one numerical summary for 1,028 individuals, but we want to generalize it to all of the teenagers in the US. We want to generalize it to the population. So that's this next thing. What would it look like if we took the above descriptive statistic and applied it to the entire population? And that is what we call inferential statistics. So that's what we're going to be doing the last chunk of class, is the inferential statistics. Okay, so just to summarize that, it uses methods to be determined later that take results from a sample and extend them to the entire population. All right, and measures the reliability of that result. All right, because again, it's just from a small subset of the population. So whatever we get from the sample, that statistic from the sample, it may not exactly match the whole population, which is why we have to do this part, and we have to measure the reliability. All right, so I'm just going to highlight that. Okay, so you have to measure the reliability. So what it looks like when we actually state our results, we would say that statistic, like the 4.9% from before, but we know that it's going to be around the actual percentage of the population. So maybe just to say, give us some wiggle room, we might add 0.5% or subtract 0.5%. And then in addition to this, we have wiggle room. We also would say how confident we are on our result of 4.9% plus or minus half a percentage. And we could say something like 80% confidence. So we would say that our result from this survey, the percentage of teenagers that have been prescribed medication for mental disorder, we could say it's about 4.9% of teenagers plus or minus 0.5%, and we're about 80% confident that this is correct. Okay, so all of these numbers, the 4.9%, that's our descriptive statistic, but this 0.5% and 80%, that's much later in our semester. So we'll be re-examining those later. That's the last part of our class. Okay, so let's summarize what we have. The process of statistics. This example laid out the process of statistics. The first one is that very first question: how many teenagers have been prescribed medication? So we are going to first identify the research objective. What question do we want answered? We're going to collect the data. So that was when the Gallup organization sampled or found 1,028 teenagers. We're going to describe the data. So in this case, it was that 4.9%. And then the last step is we're going to perform our inference. All right, and number 4 is why we have statistics. We want to be able to generalize to the general population. All right, so this actually outlines our semester. Collecting data, that's going to be chapter 1. Describing our data is going to be chapters 2 through 4. And the last part, the inference, we're going to have to take a pit stop. Chapter 5 through 8, we have to kind of bulk up our theory. And then after 5 and 8, we're actually going to be doing the inference. So chapters 9 through 13 is the inferential part of the course. All right. So take a second, read this next example, and see if you guys can come up with the research objective, what the population is, the sample, list your descriptive statistics, and the inferential part of the survey. And I will give you the solution in our next video. All right, so let's see how we did on this one. All right, so we have a financial group. It conducted a survey of 1,172 employees in the U.S. between July and August 2010. They were asked if they are currently participating in the employer-sponsored automatic payroll deduction for the 401k plan to save for retirement. Of this 1,172 employees, 27% indicated they were participating. So they reported that 20% of all employees in the U.S. participated in the automatic payroll deduction for the 401k plan to save retirement with a 4% margin of error and a 95% confidence. Okay, so what is the research objective? They want to know, and I'll just kind of summarize this. You can see it right here. These employees in the U.S. between July 2010 and August 2010 that were participating in the employer-sponsored automatic payroll deduction for a 401k plan to save for retirement. That is a long sentence. So what is the research objective? So we'll just kind of paraphrase this. Employees participating in automatic payroll deduction. And there's much more to that, but that's the general idea. On your quizzes and exams, you guys would write out the full sentence because you guys want to be thorough on your exams. All right, so what is the population? Well, the population are those employees in the U.S. between July 2010 and August 2010. Okay, so all employees. And again, all is the keyword, all employees in the U.S. between July and August 2010. All right, and the sample again is that small subset of the population. So it's that 1,172. All right, and let's remember our units. Units are the individuals, which are employees this time. And the descriptive statistic is what we're getting just from the study, and that was that 27% participated. All right, and the inferential part is that wiggle room with a confidence level. And again, we'll learn all about how to calculate that wiggle room or margin of error and how to calculate that confidence level later on in the course. But what can be inferred from this survey is that between, and let's see, they said 27% with a 4% margin of error. So that's our wiggle room. So let's subtract 4% from 27, and let's add 4% to 27. Whoops. That's different. Okay, so that was between 23 and 31% are participating. With 95% confidence. All right, so we have our wiggle room, 4%, and then we have the level of confidence. So that's our inferential. All right, and then that is that. Okay, so let's move on to new definitions. Oh, that wasn't supposed to happen. Okay, that's just how we're going to do this. Okay, so what we're estimating in Part E, what can be inferred from this survey, we're trying to estimate the percentage of the entire population. So that would be a numerical summary for all of the employees. That leads us to our next definition, the parameter. And a parameter is a numerical summary of a population. So that last part, Part E, we were estimating a parameter. So that's what inferential statistics do. It estimates parameters. Okay, so let's play a game. It's called statistic or parameter. Okay, so suppose that the percentage of all students on your campus who have a job is 84.9%. All right, so is this 84.9%, is that a parameter or a statistic? In other words, is this a numerical summary for an entire population or a small group from the population? Okay, and the key word in this case is all. So because we're talking about the percentage of all students on your campus that have a job, we're actually going to say that this is a parameter. All right, and then this is a number we actually could get many times when we enter a school. There's surveys, and sometimes a question could be like, do you have a job? So this is a number that we have access to. Let's look at the next one. Suppose a sample of 250 students is obtained, and from the sample we find that 86.4% have a job. Okay, so we would want to know, is this 86.4%, is this a parameter or statistic? What's the key word? Sample. All right, so because it's a sample, we know it's a statistic. All right, and notice that the statistic that comes from the sample, in this case, this is our statistic in this example, it's really similar to the actual percentage, all right? And that's normally what we're going to find. If we have a good sample, it's going to be really close to the actual number. All right, so in conclusion, here we go. we have, I think my PDF got a little bit messed up. We're just going to focus on this picture. That's what your data is. We want to know about this general population right here, right? But the information about the population is really hard to obtain because there's so many individuals and there's so many ways that are going to prevent us from acquiring data about every individual. So what we do when we want to know something about this population, we randomly select a small sample. And now these few individuals are much easier to work with. So from these few individuals, we gather data and we get our descriptive statistic. All right? And because this group came from this group, we're going to assume that there's some similarities between. So we'll take this statistic, this descriptive statistic, we'll do our inferential stuff, and we'll get our parameter. And this parameter, it comes from the population. So we're using statistics to estimate parameters. Okay. So we're going to start talking about these descriptive statistics. So on your handout, this is your next page. Right here, this is your next page. And it says that data varies, so it's called a variable. It can be thought of as a characteristics, and there's different types of variables. We have qualitative variables, which are describe qualities, and they're also called categorical variables. Okay, so keyword in qualitative is a quality. So quality. And again, we're on the qualitative variables. Okay, so it's a classification of individuals based on characteristics. So classification of individuals which make up a population, and they're based on attributes or characteristics. Okay, so some types of these variables, so again, don't think numbers, think words to describe them. So my husband likes shoes, so in his honor we'll say shoe brand. That's our variable. Hair color could be another one. That's our variable. The values of that variable would be like brown, red, black, blonde, etc., etc. You can talk about the qualitative variable of majors. Let's say we have some bio majors, nursing majors. Those are values of that variable. All right, eye color would be a variable. Values of that variable would be brown, hazel, green, black, blue, etc., etc. All right, and then quantitative variables. We should be thinking of, when we hear quantitative, quantity. So this is going to be your numerical values. So this is a numerical measure of individuals. All right, and then we have to be careful because when we're talking about numerical measures of individuals, we have to make sure that we can perform operations on the values of the variable. So for instance, like a phone number could be a variable, and it's definitely a numerical variable, but it's not a numerical measure. Like for instance, we can't take my phone number and add it with your phone number. So it has to be a numerical measure. So an example of a quantitative variable would be height. So, you know, like 5'10", 6'2", all of these things. And we can add feet, right? 5 plus 1 is 6, for instance. So that's okay. Age is another one. That's a numerical measure. Weight, income, etc., etc. Okay. So there's different types of quantitative variables. And they are discrete and continuous. Discrete variables, you can count their values. So discrete is associated with counting. So 1, 2, 3, 4, 5. You count children. You count how many cars you have. So a discrete variable has either a finite or countable. Number of possibilities, number of possible values. All right, so again, you can have 0 cars, you can have 1 car, 2 cars, 3 cars, 4 cars, etc., etc. You can't have like 3.5762 cars, right? That's silliness. All right, and then a continuous quantitative variable, it's still going to be a numerical measurement, and this one we're actually measuring. So when we measure things, so for instance, if you had to measure the length of a room, you can get more and more and more precise. You can measure to the nearest foot, to the nearest inch, to the nearest half inch, to the nearest tenth of an inch, to the nearest hundredth of an inch. So what's happening is we can have an infinite amount because we can get more and more precise in our measurement. So it has an infinite number of possibilities. And normally when we see the result, it's normally rounded, so we have to think of a measurement. So even though they round it, originally it could have had an infinitely many possibilities. So again, it's measured to any desired level of accuracy. All right. So what we just went over is in this nice little chart. Okay, we have our variables. That's in our first little cube. We have our quantitative and our qualitative variables. All right, so we have numbers, we have words, and our number ones can be broken down to discrete, which is counting, or continuous variables, which is a measurement. Okay, so let's play a game. Qualitative or quantitative? So the first one is nationality. So is that a qualitative or quantitative variable? And again, go ahead and pause this while you work this out on your own. And when you're ready to see the solutions, you can start playing it again. All right, so nationality, that would be a qualitative variable. Number of children is quantitative. Household income, that will be a number. So it's quantitative. Level of education, we're not talking about like first grade, second grade, third grade. Normally when we talk about level of education, like on a application, it's normally high school, a degree, a bachelor's, a master's, PhD, et cetera, et cetera. So those are all words. So we're going to say that that's a qualitative variable. And then finally, daily intake of whole grains. That would be a quantitative. All right. Let's take it a step further. Discrete or continuous. So again, take a moment, please pause it, see if you can answer these yourselves, and play it again when you're ready. Number of children, we count those. 0 children, 1 child, 2 children, etc. So that's discrete. Household income in the previous year. It's actually a measurement because especially hourly workers, sometimes we get our paycheck and it's not just like $100. For instance, sometimes after we do our wage times the amount of hours we have, let's say it's actually something like this. So $100 and 0.0056, and then your job just says that you earned $100 and a penny, right? So this is the desired level of accuracy, but we can actually get more and more accurate. So we actually are choosing from infinitely many. So again, income is it's a measurement. So this is continuous. All right, and then same thing, daily intake of whole grains, measured in grams per day. So it's a measurement. And again, measured in grams per day, normally we say like 1 gram, 2 grams, 3 grams. But really, let's say if we have like 5 grams, that's really probably some sort of range. It could be anywhere from 4.5 to 5.4 grams. Any weight that falls in this window is going to be rounded to 5 grams. So again, there's infinitely many values in this interval. So we're going to say that this is continuous because it's a measurement. All right. Finally, in this section, we're going to talk about the level of measurement. So we have our variables, qualitative or quantitative. Quantitative gets further broken down into discrete or continuous. And now something separate is we're going to talk about the level of measurement. All right, the first two, it goes from kind of the smallest to the strongest, or the least to the strongest measurement. These first 2 levels of measurement are your qualitative, and then your second levels of measurement are your quantitative. All right, so we have our nominal level of measurement first, our nominal level. And then we say that a variable is at the nominal level if the values of the variable just name, label, or categorize. The naming scheme does not allow for the values to be arranged in a specific order. All right, so then the key word to that, nominal, we can think of that as name. So all we can do is name the variable. There's no natural order. So this is like brand of shoes, eye color, et cetera, et cetera. All we can do is name it. This next level of measurement, it's a little bit stronger. It's our ordinal level of measurement. It has the same properties as the nominal level, but now we have this keyword order, or ordinal, and so we can now order them. So it has the same properties as the nominal level, and the naming scheme allows for the values of the variable to be ranged in a rank or specific order. So we're going to think order. That's our key word. Okay, so names that can be ordered. So we kind of have, let's see, a good one is the high school grade level, freshman, sophomore, junior, senior. All right, so those are words that have a natural order to them. Okay, so our next level of measurement is the interval level of measurement. It has the same properties as before. And this one's a little bit tricky, but very important. We have that a value of 0 in this level of measurement does not mean the absence of quantity. It does not mean the absence of quantity. And what we can do with these types of variables is we can add and subtract them. Okay, so what does that mean? A value of 0 in the interval level of measurement does not mean the absence of quantity. I think a good example for this one is temperature. Because let's think about 0 degrees. 0 degrees Fahrenheit, we'll say. So this doesn't mean that there's no temperature outside. It just means that it's very cold. Right? It's very, very cold. Some other examples would be clothing size. Size 0 does exist, but it doesn't mean there's no article of clothing. It just means it's very, very tiny. So 0 degrees Fahrenheit doesn't mean that there's no temperature. It just means that it's very cold. A clothing size of 0 doesn't mean that there's no size. It just means that the clothing is very, very small. All right. So finally, our ratio level of measurement has the properties of all of them before. This time a value of 0 in this level of measurement actually means the absence of quantity. All right, so these are the more straightforward types. So again, that's the important part. That's how we're going to distinguish between all these. A value of 0 means the absence of quantity. So for instance, income. 0 means you have no money. Number of children. 0 means you have no children. Et cetera, et cetera. Okay, so, and in this case, we can do multiplication and division. Right? We can do multiplication and division. So we could say something like, I make twice as much money as you, or I have 3 times the amount of children as you. Right. Notice with temperature that doesn't really work. If let's say it was 1 degree Fahrenheit and then the next day it was 2 degrees Fahrenheit, we wouldn't say it was twice as hot. It doesn't make sense. We could just really say it's a degree hotter. So addition and subtraction work better here. Multiplication and division don't work with the interval level of measurement. All right. Let's do some examples. Again, go ahead and push pause, determine the level of measurement for our final examples, and then push play when you're ready to go over them. Okay, so number of snack and soft drink vending machines in the school. We are counting those 1, 2, 3, 4, or 0. So that's ratio. We also know that if there was 0, it actually means there's no vending machines. So that's the way to tell between ratio and interval. What does the 0 mean? And in this case, 0 means an absence. There's no vending machines. So whether or not the school has a closed campus policy during lunch, the values would be yes, it's closed, or no, it's not closed. Not really a natural order. All we're doing is naming those options, so it's nominal. Class rank, freshman, sophomore, junior, senior. We already talked about that. That's your ordinal. Number of days per week a student eats a school lunch. So 1, 2, 3, 4, 5, 6, 7. You also have a 0, and 0 would mean no days. It would mean an absence. So that's your ratio. And then finally, temperature. We talked about that. 0 degrees does not mean an absence of temperature. It means it's really cold.